Hello, good morning, guys. I literally just wake up and my pain is almost full, so let's just get started. Speed up time. Yeah. So, guys, I'm done. I'm done with the leg. I'm done for today. Yeah, this is the progress for today. Ooh, it will be a big, big picture, big paintings. I don't know what to call it, but yes, I mean, tomorrow I will like do this. Ooh, I can see. I can see. Ooh, it's really cool. So yeah, guys, I will stop recording first. See you. So guys, I'm back. Ready to take a bath. I already eat. Now it's time to continue. I see that there is still a long way to go, right? I have 37 video from Brawl Dev. And after that, I will go to GUI. And then I also find this one video which tells me that there is a proper setup for the Roblox studio, right? Roblox studio is just not that good, they say it. And then I will be using like VS Code or something. But before that, I'll learn this first, okay? I'll think about the setup later. But right now, I'm focusing on learning the fundamentals, the core fundamentals. Now I have been coding. I think this is day 11, right? So today I'll finish 2 videos and then I'll go because today is Saturday. So yeah, let's just continue.
Hey,
Wait, you cannot see the Roblox studio yet? Oh, here you go. So I will be focusing on learning more than making games because when I think about making games, right, we need to like implement things and then it teach me a lot of things. It taught me a lot of things. When I'm making games yesterday, it taught me like how to implement stuff better and yeah, there is just a lot of stuff that you need to think about. And when you're starting with this only best plate, like it's not that easy, right? It's not that easy. Like if you want to think about making a game, so you need to do it one by one, like making the button, making everything one by one, making the core mechanics. And I think I learned a lot of things from that. But for now, I'll green on the fundamentals first, okay? And and then if there is a challenge that really needs me to make a game, then I'll make it. So yeah, I'll continue. I will focus on this one thing and one thing
hey,
only.
thanks for stopping by. We're going to be introduced to a new data type that Roblox has provided for us called Vector 3. So pretty much a Vector 3 is
like that. Factor 3. We are on factor 3, and I already know that factor 3 can like put 3 stuff. It's like color 3, but it's factor for XYZ, right?
a value that allows us to manipulate specific properties inside of our 3D world, usually with things that have to do with positioning of parts inside of our world. So it's definitely a very powerful data type, which is why we're going to be introduced to how to use vector 3s inside of our 3D world through scripting. And so I basically whipped up like a little example here with this part. So basically what should happen is something magical when I click this part. What happens is when I click it, then, bro, this part is just flying by. It's just like sliding all the way out to somewhere that's not close to me because this part does not love me. But yeah, I basically just constantly change the value of one of its positional values to go in this direction forever and ever after I clicked on it. So this is with the use of vector 3, and I'm going to be showing you how to do this. But before we start implementing vector 3s, I want you to really understand how this all works, and I'm going to do that by showing you an example. All right, let's think about this for a minute. So I'm in a game of Minecraft, and I know it's kind of weird, but trust me, it'll make sense. Minecraft is a 3D game, and it has a 3D world that has 3 directional values that correlate to the location of where the player is inside the game, called the X, Y, and Z coordinates. And if you want to see these coordinates, you have to press F3 on your keyboard like this. That shows a bunch of statistics of the world that you're currently playing, but we're mostly interested in the X, Y, and Z values on the left side. So as you can see, our X, Y, and Z value, our X being negative 16, our Y being 63, and then our Z being 239. If we move around inside the workspace, these values are changing accordingly to where we are inside the world. So if I move in this direction, then it's increasing the X value every time we move in this direction. So this is called the X direction. And if we move backwards, then we're decreasing our number in the X axis or coordinate. And now let's say we go this way. This is increasing our Z value every time we move forward inside of this direction. But if we move backwards, then it's going to continuously decrease our Z value the further we go backwards. And the Y, which is the second value, like how high we are in the workspace right now. So if I just fly up, then you can see that our Y value is constantly increasing. And if I just drop back down, then it goes all the way back down to where we are inside of the world. So these are the 3 positional values that represents a vector 3 if you were to compare this to Roblox. But it's essentially the same idea. So this was just something I wanted to show you before we start implementing this stuff, just so that you can get a better understanding of what the heck a vector 3 value is. It's pretty much a vector that comprises of 3 values called the X value, the Y value, and the Z value that can be used to change values of parts that are inside of our Roblox world. Not just with positions, both sizes and rotation and all that sort of stuff. So that's what we're going to be doing in this episode. Now that we understand it, let me show you what a vector looks like inside of Roblox Studio. So on the top right of the screen, I don't know if you have this, but this essentially shows us our directional values with X, Y, and Z to tell us where inside of Roblox Studio our 3 axes are located. So if we go this way, then it's going to increase our X value. If we go backwards, it's going to decrease our X value. And if we turn around this way, then we increase our Z value by going this way. And of course, the Y value, it's basically determined by how high you are versus how low you are. So now let's translate that to a part when we insert it inside Studio. So let's go up here to Model and hit Part. So with this part, we can come down here to C frame, and we can see that there's a
What is this? Wow, new things.
property called position. Ignore this position that's inside the origin category. We're mainly focused on the C frame position. So this one a part when we insert it inside Studio. So let's go up here to Model and hit Part. So with this part, we can come down here to C frame, and we can see that there's a property called position. Ignore this position that's inside the origin category. We're mainly focused on the C frame position. So this one basically shows us our X, Y, and Z coordinates, just like in Minecraft. So if we select this part, select move, and move it in this direction, it increases our Z value. If we make it go back this way, it decreases our Z value. And if we make the part then just goes back down here. So that's pretty self-explanatory. We can even change individual values of our X, Y, and Z position. So we can make this 5, for example. This just makes it 5. And then for Z, we can make it 10. It goes this way. So you get the basic idea. Our position consists of 3 values, X, Y, and Z, that's basically contained inside of one data type called a vector 3. And now I'll show you what it looks like in a script. So what we're going to do is on the right side, let's click on the plus sign at part, and let's insert a script. And we're first going to make reference to our parts, which is going to be local part equal.
Okay, guys. So from now on, I will be on a learning spree, right? I'll focus really hard. And once I already know this thing and I already know that thing, I will not be implementing that again. So I'll be following things that I don't really understand yet, or I want to clarify something. So that's what I'm gonna be doing. So I'll not be doing like all of the stuff that he do. Like I'll only follow what I think that I don't understand or I want to clarify something. Yeah, I think that's it.
Equals script.parent. And then what we'll do is we're going to change the position of the part when we run this script inside of our game. So when we run this, dot negative here, right here, negative 12, 0.5, negative 11, to this C, the script right here. And it automatically changed the game, hit test. We're going to hit run because we don't need to play the game in order to see this. And as you can see, the script ran and it automatically changed the position of this part when we ran this script to change its position to this new value right here. So To reiterate, a vector 3 is a data type that holds three numbers, the x value, the y value, and the z value, to change the position of this part. But vector 3s can be used for other things other than positions. So if we look more into this part, let's look at some properties that also have three values. So for instance, our size has an x, y, and z. Our orientation, also known as our rotational value, has an x, y, and z, so we can use vector 3s for that. And then some other complicated stuff like assembly linear velocity and assembly angular velocity that also has x, y, and z values. So anything that has three values that are comprised of x, y, and z coordinates is deemed a vector 3 data type. Now let's do some vector operations. And what I mean is adding, subtracting, multiplying, and dividing, like all those basic operations with multiple vectors. And I'll show you a really easy example for this one. So if we select our part, I don't know if you noticed, and we have it selected to our move tool, then it automatically shows our x, y, and z axes to be able to change the location of the part. But now what we're going to do is basically take the position of this current part and add a new vector to it so that it'll just move in a certain direction rather than having a whole new location. And we're going to do that first by changing the position of this to something very easy to grasp. So let's just highlight this and make the position at the origin of 0, 0, 0. So we're going to select position and we're going to put in a 0, 0, 0. And so that's going to be located at the very origin. Let's take our spawn location and just move it a little bit so we can see this part. And now our part is in the origin of the world. But let's also move the base plate down a little bit so that the part has room to be able to move freely without being clipped through any parts. So let's change the y value of the base plate to negative 8.5. So now we should be able to see the part freely over here with no issues. Let's also move this spawn location over here. Okay, now essentially what we want to do is take this part, have its current location, which is 0, 0, 0, and add a number that goes in the z direction. Like let's say 5. 5 in this direction. So first what we're going to do is go to our script and let's delete this new vector 3 value that we created. And how we're going to change this position is by obviously getting the part position first. So we're going to say part.position plus vector3.new, and we want to just change the z value to wherever it currently is plus 5. So what we're going to do is first put in our x value, which is going to be 0, comma, our y, which is also going to be 0, and then finally our z value, which is going to be 5. So basically, we're going to take the parts position, which is just 0, 0, 0, and then add that to a new vector with 0, 0, 5. So in the end, this will end up resulting in a new vector 3 position that is 0, 0, 5. So let's see what happens if we hit test and hit run. We should see that when the script fired, it moved the position of this part to what it was at the beginning, which was 0, 0, 0, and then to 0, 0, 5. And the reason it looks like this is because we have the part anchored, so it was impacted by gravity a little bit. Let me just anchor this part so that we can really see the new vector change. So if we select the part again, then as you can see, our position is now 0, 0, 5 because its original position before the script ran was 0, 0, 0. And then we added a 5 to the z value to make it 0, 0, 5. I hope this basic example makes sense a little bit because when we use vectors, we are going to be using computations to get a new result from different vector values, like adding vectors, for instance. And there's also another way of writing this too. Instead of just reiterating part.position equals part.position plus vector3.new, what we could do instead is delete this first part and we can just put in a plus equals. This basically means the same thing as the one we just had before, where we basically take the current part's position and add a new vector to that position. And we should just get the same exact result. It really comes down to preference which one you like to do more. I'm just letting you know this is also another way of just taking the current part's position and adding a new vector to it. We can even do this with subtraction, and there's two ways of doing subtraction. So the first way is just taking part.position and then subtract equals vector3.new 0, 0, 5. So just to make this easier, let's change the syntax to part.position minus instead of what we had before. So the part's position is going to be whatever the position it currently is, and then subtract that by our new vector here. Now you have to be careful that this is supposed to be a 5 and not a negative 5 because we are subtracting this vector. So if we have a 5 here, this essentially means take the z value and subtract it by 5. So if we go into the game, we should see that the z value will go in the other direction, so it goes back here. So our z value is now negative 5 and not 5. There's another way of writing this. We can actually do part.position plus vector3.new negative 5, and this should basically give us the same results as subtracting a vector 3 of 5. So as you can see, it basically did the exact same thing as we did with subtraction, except we kind of just flipped the signs around because as you know, how. And then of course you have multiplication and subtraction, which I hope you know how those two operations work. So the way multiplication works is we're going to replace this plus sign with an asterisk. So this represents multiplication, and we're going to multiply the current part's position to whatever new value we have here for vector 3. Let's get rid of this z value by putting in a 0, and let's change the x value to 2. So what it's going to do is it's going to take the x value of this part, which is 0, and it's going to multiply it by 2. Now what should happen is that it's still going to be in the same place as it usually is because 0 times 2 is 0. So let's actually change this position to 1 so that we can effectively see the multiplication that we do with this part. So it's a very small difference, but as you can see, our x value changed to 2 because 1 times 2 is 2. You get the idea. I hope so far this is making sense to you. And you can pretty much do the same thing with division. It's basically a / to represent division. And you basically get the idea. I hope so far this is making sense to you because there is a bunch of math required when it comes to vector 3 values. In due time, the more you practice, the more you'll definitely get better at it, so I believe in you. But anyways, we dealt with changing the position of this part, but there are other values we can change that uses vector 3 values like size and rotation, or orientation in this case. So let's change those values. And so the way we change the size of a part inside Studio is by going to model and going to our scale tool, and it's basically the same way with the z value position. So let's go to our new, and we can put in some value like have, and 4. So it's going to change the size of this 4. And we can even do the same thing with rotation at 3. So as you can see, say 25, 0, 25. Let's see what that results in when we hit run. So as you can see, the orientation or the rotation of the part has changed accordingly to what we z value and a vector to then change every value that's in the vector 3 value. And I'll explain take the inside the game. Another thing we can do is multiply and divide a vector with just a number. So in this case, what we can do is we can take the position of our part and just multiply that vector value by a number to then change every value that's in the vector 3 value. And I'll explain to you what I'm talking about. But first, let's change the base position of our part. So we're going to go down here and let's change this position to 1, 0, and 1. And let's go to our script. So let's delete these two lines of code right here. And the first thing we're going to do is say part.position equals part.position, and we're going to multiply this by a number. So we'll say times 5. You can take a guess what's going to happen here, but essentially, it's going to take every value that's in this vector 3, which is 1, 0, and 1, and multiply all the numbers by 5. So our x value is 1, so 1 times 5 is 5. So if we select this part, we can see that the new position is 5, 0, 5 because we took the original position of the part, which is 0, 1, 0, and then we multiplied all those small number. So it's going to have a very small difference. But let's see this very small difference in play. So I hope that part makes sense to you. We're going to create a practical use case of vector3 values by creating a teleport script whenever the player joins the game. Let me show you how this is going to look. So first thing we're going to do is create a new part. So let's go to model, part, and let's rename this part to teleport part. Let's even change the color of this to blue, and let's move this over here. Now what we're going to do is create a script inside of server script service, like so. And then what we're going to do is create a player added event. So game.players.player added connect function, open parentheses, close parentheses, enter. The parameter here is going to be player. One thing we have to do is know how we can actually teleport our character to another position inside of the game. So I'm going to show you how we're going to do that right now. If we open up Workspace and go to our character and open this up, we can see that there's a part here called humanoid root part. It's kind of hard to see the humanoid root part, but essentially it's like an invisible box that's surrounding our torso area, much like our upper torso. So we can actually see our upper torso here, but our humanoid root part is like this invisible part that basically connects all the attachments to our character together into one. And so we're going to be changing the position of this humanoid root part to the position of our teleport part in order to move our character from where we currently are to that part over there. So that's what we're going to be doing. So now that we understand that, let's locate the humanoid root part by first making reference to the humanoid root part. So we're going to say local complete a humanoid root part exists inside the character. So locate the humanoid root part by first making reference to the humanoid root part. So we're going to say local humanoid root part equals player.character, and we're going to wait until the player's character completely loads into the game. So root part equals player.character. And we're going to wait until the player's character completely loads into the game. So we're going to say colon wait for child. So we're going to have the script wait until a humanoid root part exists inside the character. So in quotations, we're going to say humanoid root part. And then down here, we're going to say humanoid root part dot position. So we're going to modify the position of the current humanoid root part equal to game.workspace.teleport part dot position. So in these two lines of code, we're basically getting the humanoid root part from the player's character, and then we're going to change that position to the position of this teleport part over here.
Something's wrong. I don't know what.
The humanoid root part from the player's character, and then we're going to change that position. So there's a little arrow function, or we can position of this teleport part over here after the player has joined the game. So if we hit play, okay, so there's a little error here. There isn't enough time for the script to wait until the player joins the game. So we can either do this in two ways. One is by adding a task.wait function, or we can add in another event that calls the character every time the character loads into the game or resets. So for the sake of simplicity, let's just add a task.wait to this event. So we're going to say task.wait. And then we're going to wait 5 seconds before the script runs. So let's go to the game and hit play. And after we wait about 5 seconds, it's going to locate the character's humanoid root part, and then we should be able to teleport just fine. So as you can see, our character did indeed teleport to the part's position, but then we kind of slid off a little bit because if we're teleporting our player to the direct position of this part, it's going to literally be inside this part. So what we can do, we can add a Y value of 5 so that the player spawns right on top of the part, not in the part. So we're going to go over here, and let me just zoom out a little bit, and we're going to add in a new vector by saying plus vector .new 0, 5, not inside the part. I hope this introduction to vector 3s served you well. I'm not going to go over every single thing that vector 3s have to offer because this just serves as an introduction to get your foot in the door to be able to understand vector 3s for your future Roblox projects. Because vector 3s, it's a complicated data type and it'll only get more complicated from here. So I highly encourage you to read the documentations for vector 3s, maybe look at more tutorial guides from other YouTubers who've talked about vector 3s as well, so that you can really understand how you can use these vector 3 data types in your Roblox games. Again, I hope this introduction to vector 3 served you well. Continue to improve your Roblox developer skills because sitting down and struggling through things that are tough for you will make you a more competent Roblox developer in the long run. And I believe you got this. So that's gonna be it for this episode. Join my Discord server. The link is in the description, and I will see you in the next episode. Take care. I didn't know there was a disco going on here. Oh well, I'm not gonna question it. I just find it to be pretty crazy that these two parts are essentially changing colors just simultaneously at the same time, especially when it's looping through so many different parts at once. You wouldn't really be able to do this inside of a standard script unless there were multiple tasks running at the same time. I think what I just explained pretty much sums up what I'm going to be talking about in this episode, which is kind of a part 2 to my task functions video that I made a while ago. Having the ability to do multiple tasks in the same script is something very powerful. That's pretty much with the use of coroutines, and it's important to understand that there is a difference between coroutines and task functions and why I made them in 2 separate videos. So this will pretty much be a continuation from my task functions video into another multitasking system that is honestly better than task functions depending on how you use it. And so that's what I'm going to be showing you how to do inside of this episode. All right, let's think about this for a minute. You seem to really like my example previously with task functions when I created all these tasks represented as parts. So I pretty much brought it back, but this time with coroutines. So what's the whole idea of coroutines? Well, pretty much it's kind of similar to task functions in a way how we want to create multiple threads to be able to run multiple tasks at the same time using the same script so that we can basically do a whole bunch of stuff simultaneously without having to wait for whatever is previously in the script to then run whatever else is underneath it. So we basically have these tasks here, and we have coroutine functions that relate to what we're going to be discussing about inside of this episode. So let's say we have task 1 and task 2. We want to be able to run these two tasks at the same time, but how do we do that? Well, what we would do is instead of writing all of this inside one thread, we can create a new thread and make it wrapped around inside of the second task we want to do. And this is a concept called multi-threading. So we would basically do that by creating a new coroutine thread and just slap this inside of task 2 so that we can run both of these at the same time. But just creating the task is not going to be enough. We have to actually execute the task as well by using resume to then actually execute the coroutine task that we created inside of our script so we can run task 1 and task 2 at the same time. Now, so far, this looks pretty similar to task functions, but there is one key difference between task functions and coroutines is that we have the power to pause these multi-threading tasks using a function called yield, which basically says during execution of our coroutine, we can literally pause the task in order to do other things outside of this multi-thread first before going back into this task to do whatever we want the task to do. So basically, if we yield this task, then we're not resuming this task anymore. And in order to make this task run again, we would just simply use resume, get rid of the yield, and then the task would be running just like normal. And so if at any point we don't need to run the complete version of this task anymore, or just things in the script have changed, then we can just simply close the coroutine task and create a new one. So it basically just gets rid of our coroutine task that we had previously. And so this is just a couple methods used for coroutines. Yielding is probably the biggest game changer for these multi-threaded tasks inside your scripts. And that's what we're going to be doing inside this episode. It serves as task functions with more control over your multi-threading processes. So I hope that makes sense to you. And now And that's what we're going to be doing inside of this episode. It serves as task functions with more control over your multi-threading processes. So I hope that makes sense to you. And now let's get to implementing. Now that we understand it, let's use coroutines to create multiple threads so that they can all run at the same time using the same script. So on the right side next to server script service, we're going to hit the plus sign and we're going to create a new script. Before we start writing, here's what I want you to understand about coroutines is that when you create a new coroutine, it should be placed inside of a variable. And when we check to see what this coroutine actually is, it's basically a thread object that has different functions that we're going to be using inside this episode. So let's create a variable. And this one is going to represent our second task. So in double dashes, we're going to make a comment by saying task 2. And then down here, we're going to create a coroutine for the second task. So we're going to make a variable by saying local, and we're going to call this task 2 equals coroutine.create. So this is pretty much the method we're going to use in order to create a new coroutine and set it equal to our second task. So in this coroutine, we're going to make a function by creating one inside of these parentheses. So we're going to say function, open parentheses,
execute alongside the main thread.
close parentheses, hit enter. So this is pretty much the general structure of creating a new coroutine and saying it equal to a variable. If we try and print the new coroutine that we just created, so let's drop 2 lines and then say print task 2. If we go into the game, hit test and hit run, and we look at the output, we can see what kind of variable our task 2 is. So it pretty much printed out a thread object, and all these numbers basically mean what created. So let's drop 2 lines and then say print task 2. If we go into the game, hit test and hit run, and we look at the output, we can see what kind of variable our task 2 is. So it pretty much printed out a thread object, and all these numbers basically mean the location in memory that this new object was created in. This part does not really matter too much, but what does matter is that our coroutine that we created is basically a thread object that has functions that can be used to manipulate when we run these coroutine tasks. So let's hit stop and let's go back to our script. So now that we know that when using coroutine create, we basically create a new thread object, and we set that equal to our task 2 variable. So let's delete this print statement here, and now we can write stuff inside of this new coroutine that we created, this new coroutine task that we created. So we can just make a print statement here by saying print coroutine task, and then we can drop 2 lines down here. So there we go. We basically created our first coroutine. But if we try and run the game, this task isn't actually going to run because we tied it into a variable. So now we have to execute task 2. And the way we're going to do run on its own, we basically have to do that manually. So what we're called resume, because by default, when we create a coroutine, it's not going to run on its own. We basically have to do that manually. So what we're going to do down here is basically write coroutine.resume, and then in parentheses, we're going to put in our coroutine that we created, which is task 2. So now if we hit run, we should see our coroutine executing. So down here it says coroutine task because we created a coroutine and then we used the coroutine.resume function and we pass in our task 2 coroutine to actually run it. There's different states to these coroutines, which I will explain later on in this episode, but that's just something for you to know about for now. Now, it might seem kind of unusual that we're creating a task down here. So there we go. We basically created our first coroutine, but if we try and run the game from coroutine called resume, because by default, coroutine, but if we try and run the game, this task coroutine down here is basically right coroutine.resume and coroutine to actually run it. This is going to blocked comment statement wrapper functions. So the way it's going to look is we're going to first create a task. Now, it might seem kind of unusual that we're creating a task wrapped inside of a variable, and then we're just calling coroutine resume on that coroutine that we created. It seems like a weird structure. However, there is an easier way to write this, and this is going to use wrapper functions. So the way it's going to look is we're going to first create a task, and then we're just going to call that task after we created it. Let's make a blocked comment statement by selecting up here, and we're going to put the 2 dashes, but also put in 2 open hard brackets, and then at the end here, we're going to put in the closed end brackets by putting 2 of them here. So now let's drop 2 lines, and what we'll do is we'll create a variable, and then we will wrap this around inside of a coroutine wrap function. So the way it's going to look is we're going to first create a variable, which is local task 2 equals coroutine.wrap, and then inside of here, we're going to create another function, open parentheses, close parentheses, enter, and let's make our same print statement. So we're going to say coroutine task. And so right now, this looks pretty similar to our first coroutine task. But what we can just say down here is task 2, and then put in the open and close parentheses. And this is basically all you need to do. So it's a little more simplified than what we had up here, but both of them generally do the same exact thing. So if we hit run, then we should see the exact same result, just like in the first example. So just print coroutine task. after we created a wrapper function called that function just by its name with the open and close parentheses. So that's another way of writing it. And if you want to further simplify this even more, what you can do is not even have a variable here, just like get rid of the task2 variable and get rid of this down here as well. And we can simply just put in two parentheses right at the end. So this is all you need to say. It's just basically 3 lines that creates the coroutine wrap function, and then it prints whatever's down here, and we end it with the open and close parentheses. So this is also another really simple way of writing these coroutine threads. However, the issue with writing it like this is that we're not able to retrieve this coroutine once we're done executing it because we didn't wrap this inside of a variable. So I do want you to be cautious if you do write it this way. There's also one more way I can think of when writing these wrapper functions inside of these coroutines, and that's by wrapping a function inside of a local variable and then just using coroutine.wrap surrounded by that variable, these coroutines. And that's by wrapping a function inside of a local variable and then just using coroutine.wrap surrounded by that variable and just call that within one line. So we're going to make a function that's wrapped inside of a variable. So we'll say local my function equals function, open parentheses, close parentheses, enter. And we just put in some random stuff in here, print function. And then down here, what we're going to do is say coroutine.wrap. And then inside of here, we're going to put in our function. We're going to say my function and then open parentheses, close parentheses. Just like this. This is another really easy way to write a coroutine. And of course, this isn't the only way you can write a function signature. You can also just say local function, my function. Of course, this isn't the only way you can write a function signature. You can also just say local function, my function, open parentheses, close parentheses. And this is also another way of doing it too. So I just wanted to throw these two examples. This is another really easy way to write a coroutine. And of course, this isn't the only way you can write a function signature. You can also just say local function, my function, open parentheses, close parentheses. And this is also another way of doing it too. So I just wanted to throw these two examples out there as well. There's multiple ways to do this stuff, and it's just a matter of understanding these different structures of creating these coroutines. All right, and since we are writing functions inside of these coroutines, it actually is possible to pass in function arguments. And I'm going to show you this by using our last example. So let's uncomment our previous example, and let's comment our new example because we will hopefully come back to this as reference. What we can do here inside of our function declaration, is add extra parameters in here. We can put whatever arguments we want in here. Let's make a system where we pass in two numbers, and we're going to print the sum of those two numbers. So let's make the first argument num1 for number 1, and then comma num2 for number 2. And then down here, what we're going to do is print num1 plus num2. And so now the way we pass in arguments into this coroutine function is by going to where we call this coroutine thread, and we just simply put in the thread itself, and then we space it with a comma with whatever other arguments we have after that. So this one is going to be our number 1, and then we put another comma here, and this one's going to be number 2. So once again, when we call coroutine resume, we have after that. So this one is going to be our number 1, and then we put another comma here, and this one's going to be number 2. So once again, when we call coroutine resume, we're first going to pass in our coroutine thread, and then everything after that is going to be the function arguments. Our result, so when we load into the game, it should say 4 because 2 plus 2 is 4, and then it's going to say coroutine task. So let's run the script and see our output. So yeah, it printed out 4, and it also printed out coroutine task like expected. Now let's try running multiple tasks at the same time. So you know how 2 loops go, right? If it's 2 while loops, for instance, let me just write some comments here so I can get you to understand this analogy. So if we have 2 while loops, while, true, do, and then it's going to end with an end here, and we have another while, true, do statement, and end it right here. Basically, what this is saying is that we're going to constantly going to this one, but in this case, we would use coroutines. So let's delete everything that's inside of the script as of right now. So let's delete all this, and what we're going to do is create 2 loops that'll run simultaneously at the same time while the game is running in order for this to work. So what we can do is create one coroutine for one of our loops and then just call the other one normally. For our first one, we're going to say local in order for this to work. So what we can do is create one coroutine for one of our loops and then just call simultaneous case. We would use coroutine. First one, we're going to say local loop 1 equals coroutine.create. Of 0.01. And what we'll do is execute this coroutine by saying coroutine.resume, open parentheses, close parentheses. And what to do is run two. So this is our first loop. When we run the game, then what we should see is task 1 that's constantly being printed into the output, as you can see right here. But what we want to do is run two while loops at the same time. So after our coroutine resume, we're basically going to do the exact same thing we did here, but instead it's going to be within the main script, not inside of a thread. So we're going to say while true do, enter. Then we're going to make a print statement by saying task 2, and then down here we're going to write another task.wait statement with 0.01 as our wait counter. So now if we go into the game, we should see both of these while true do statements running at the exact same time, back to back. So inside the output, we can sometimes see task 1 printing before task 2, and then task 2 printing before task 1, but generally speaking, they are running at the exact same time during execution. So that's one of the benefits of using coroutines, is by being able to run multiple tasks at the same time. Now you remember how I mentioned that when we create the coroutine, that doesn't automatically mean that it's executing, because what's happening is that when we create a thread object using coroutine create, we have to manually execute it ourselves because these coroutines have different states of operation, if that makes sense. So when we create our coroutine, the state of the coroutine is basically one that's not executing, so it hasn't started yet. And these are called coroutine states. So there are 3 core states we should know about. If I drop a couple lines down here and just write this down inside of my script right here, well, there's actually technically 4, but there's only 3 that we really need to know about for this episode. The fourth one you can do more research if you decide to go more deeper into these core but these are the 3 that we need to know about. The first one is suspended, the second is running, and then the third one is dead. And basically what's happening is that when we first create a core it's automatically going to be in the suspended state, meaning that it's not currently running, but that also doesn't mean it's dead. It just means it's at a pause. Running means that obviously the core is currently running or currently executing as we speak when we check the status. And then dead pretty much just means that the core is either over or it got canceled, and this core can no longer be used afterwards. And we can check these statuses by using a function simply called core.status. So we can do that by dropping a line here right before calling core resume. We can write a print statement over here and just simply call our core. So we can do that by dropping a line core can no longer be used afterwards. And we can check these statuses by using a function. Just simply call our core status by saying core.status, and then inside these parentheses we're going to pass in our core loop 1. And let's do the same thing after our core resume as well. So we can check to see the statements that we're trying to look our core in real time. What we're going to do is actually we're going to comment out these while core executed. Our status of our loop is now dead, meaning that we can no longer run it, and we're just going to have to create a new core for our core executed, our status of our loop 1 core is suspended because nothing ran yet, or it's currently paused. And then after our core executed, we check the status and it's now dead, meaning that we can no longer run it, and we're just going to have to create a new core again afterwards. So that's a pretty neat thing to know about when we want to check the status of our core to see whether we can either continue with our core see what happens. So as you can see, before our core executed, our status of our loop 1 core is suspended because nothing ran yet, or it's currently paused. And then after our core executed, we check the status and it's now dead, meaning that we can no longer run it, and we're just going to have to create a new core again afterwards. So that's a pretty neat thing to know about when we want to check the status of our core to see whether we can either continue with our core or we reach a certain point where we just don't want to use it anymore. This is a great way of checking whether that can be done or not. And finally, we are at the last part that makes core very useful, and that is with the use of their yield function. So and it's now dead, meaning that we can no longer run it, and we're just going to have to create a new coroutine. As you can see, before our coroutine executed, our status of our loop 1 coroutine is suspended because nothing ran yet, or it's currently paused. And then after our coroutine executed, we check the status, and it's now dead, meaning that we can no longer run it, and we're just going to have to create a new coroutine again afterwards. So that's a pretty neat thing to know about when we want to check the status of our coroutine to see whether we can either continue with our coroutine or we reach a certain point where we just don't want to use it anymore. This is a great way of checking whether that can be done or not. And finally, we are at the last part that makes coroutines very useful, and that is with the use of their yield function. So to explain what a yield is, this function basically stops the coroutine with whatever it's doing in order to do anything else that the script needs to do. And if we needed to, we will resume the script again to then continue off whatever it was trying to do with this thread without completely getting rid of it. Let me show you. And if we needed to, we will resume the script again to then continue off whatever it was trying to do with this thread without completely getting rid of it. Let me show you what I'm talking about. Let's delete all of this code that we have here and let's create a new thread. So we're going to call this one local loop thread equals coroutine.create function, open parentheses, close parentheses, enter. What we're going to do is make a while true do statement. So let's say while true do. Let's delete all of this code that we have here and let's create a new thread. So we're going to call this one local loop thread equals coroutine.create function, open parentheses, close parentheses, enter. What we're going to do is make a while true do statement. So let's say while true do. Let's create a for loop. Let's say for I equals 1, comma 10 do. So this is going to execute 10 times whatever's inside of here. We're going to write a print statement by saying print I. Just simply, it's just going to print whatever the current number is here. And let's also execute this coroutine. So we're going to say coroutine.resume, open parentheses, close parentheses, loop thread. So what this should do is if we run, then we should see all 10 numbers being printed onto the output all at the same time. But what if we wanted to stop execution of this coroutine to do other things afterwards and then resume this coroutine again to continue what it was trying to do before in the state that it was when we told it to pause? This is where yielding comes in. And let me show you what it looks like. So we're going to drop a line after the print statement and we're going to say coroutine yield, open parentheses, close parentheses. This is pretty much what it's going to look like right here. So what happens is that when we call resume to execute this loop thread coroutine, it's going to start at the first position of the loop. It's going to print 1, and it's going to pause execution of this coroutine wherever it is. And let me show you what that looks like. If we hit run, we should only see 1 being printed because we told it to print 1, and then we told the execution to stop. Now let's see what happens if we add more onto this. Let's drop 2 lines down here, and let's write a print statement here saying execution has stopped, and let's drop another line. Here's how we can resume the thread. And you guessed it, we're basically going to write another coroutine.resume, and we're going to throw in the loop thread coroutine. Now, what should surprise you is that when we call for the first coroutine and it's going to print the first number here, you might think it's going to do the same thing again for for the print statement by just saying print 1. But here's what's actually going to happen. Let's hit run, and what should happen is that it's first going to print 1 because we called execution, so it's going to start at 1, and it's going to print 1, and it's going to pause the coroutine. And then once this is done, it's going to go down here to print execution stopped, and then we come down here to resume or continue the coroutine of loop thread. It's going to pick right back up where it left off after this coroutine yield was over. It's going to go back to the top and increment 1 to 2, and then it's going to print 2, and then it's going to yield again. So we can just continuously do this by saying execution is stopped, and then it's going to resume the thread again to print 3, and it's just pretty much going to keep doing this. So this is going to happen exactly 4 times. So it's going to print 1, execution stopped, print 2, execution stopped, print 3, execution stopped, and then finally it printed out 4. I will go into more detail with yields, but just for a quick minute, I'm going to introduce one more coroutine function, and that is coroutine close, which just simply ends the coroutine, and we just won't be able to use it anytime afterwards unless we create another coroutine. So what we can do is that after, let's say, the second execution, let's drop a line down here, and we're going to say coroutine.close, and then inside the parameters, we're going to throw in our loop thread that we created. So pretty much what's going to happen here is that when we close the coroutine, we're not even going to be able to resume these threads because we already closed this loop thread, so it can no longer continue what it was trying to do. So if we hit run, what should happen is that after our second execution, then it pretty much printed out execution has stopped, but then it tried to resume the thread, nothing happened, and then it printed out execution has stopped once again, but also it tried to resume the thread once again, but it did not work because our coroutine is already dead because we called close on the coroutine. So that's another coroutine function I want you to know about when you're handling these coroutines. Another thing we can do is return values when we call coroutine yield. So we can actually put in parameters. So we can actually put in arguments here for when we decide to return something after we pause our coroutine thread. So what this will look like is this is pretty much going to be returned when we call coroutine resume, because when we call coroutine resume, that's when we start the thread of whatever's inside of here. And then when we call coroutine yield, it's going to return whatever arguments we put inside of here back to coroutine resume. So we can actually wrap this coroutine resume inside of a variable we call coroutine yield earned when we call coroutine resume, because when we call coroutine resume, that's when we start the thread of whatever's inside of here. And then when we call coroutine yield, it's going to return whatever arguments we put inside of here back to coroutine resume. So we can actually wrap this coroutine resume inside of a variable. So before coroutine resume, we can say local success equals coroutine.resume loop thread. And what we can decide to put in here is just put in a boolean here, just say true, basically indicating that this yield has been successful. Now, obviously, this is kind of an arbitrary example, but what I'm trying to get at here is that you can pretty much put in any arguments here and pass it back to coroutine resume once execution's over into our new variable. So we can drop a line here and then print our variable true. If we hit run, it's first going to print the 1, and then it's going to print our return value, which is true, back into our variable success after we call coroutine.resume, and then we can print that here in the output, which is going to be true. So that's another interesting thing you can do with coroutine yield is return arguments in case we want to pass in any information from yielding to then do other things with it. We can pass in as many arguments as we want. We can say true, we can say, I don't know, the number 5, we can say a string,
Mm.
that's just false or anything like that. And we can do that as long as we fulfill the number, and this is going to be results, or just anything. It can be whatever you want it to be. And we can print all of these out here in the output too, with number and result. Okay, there's a little mistake here. So when we return a yield, it's automatically going to implicitly return true. So what this would look like is it would actually return true, true, 5 false, because the first true is already passed back into this variable success. So what it's actually going to look like is it's going to be success, and then it's going to be whatever results we have after that. So it's pretty much going to look like this. We have our first result here, which is true, so we're just going to call this result 1, and then we have our second result, which is 5. We'll call this result 2, and then finally result 3, which is false. We can print all these variables out. So result 1, comma result 2, comma result 3. So this is pretty much how it's going to look like. Success is going to implicitly be returned to let us know that the yielding was successful. And then we have result 1, which is tied to true, result 2, which is tied to 5, and then result 3, which is tied to false. So if we run the script now, we should see all of our arguments being printed inside of the console. So we first have our 1, and then we have result 1, result 2, and then result 3, which is true, 5, false. So it basically works as intended. All right, now you might be sort of confused when we would use coroutines inside of our Roblox games when we're creating them, because so far what we just did with our scripts just looks like a whole bunch of concepts just scrambled on together inside our script without really doing much. So let me just lay down a couple of ideas of when you would potentially use coroutines during your development. There's a few ideas I can think of off the top of my head. One of them that sticks out to me is a countdown timer. So if you're playing a round-based game, for instance, you want the timer to constantly be decrementing the timer every 1 second, while other things are happening in the round other than just waiting for the timer to be over, like giving the player weapons, making changes to the map, having events happen. There's a whole bunch of things you can do with a round-based system, and you want the timer and you want the countdown timer to be one of them, not the only thing happening. So that's one example. Another one could be a wave-based enemy spawning system, where like let's say you're playing a tower defense game. You want the waves to be split up into different chunks throughout the entire match, and you don't want all the zombies to be spawning in continuously at once during the whole game. You want to break them down into waves, and within these waves, you want to wait for all of the enemies to be killed first before moving on to the next wave. That's another example I can think of using coroutines, but the imagination is definitely left to the creator's mind. So there's definitely use cases for them. You just have to know what feels right to you. And I believe in your ability to do that. You might also ask, what's the difference between task.spawn and using coroutines? So if you remember from my task function video, I basically stated that task.spawn is used to simultaneously run a task alongside a different task. But here's the thing about coroutines. One of the things that makes coroutines special is its use of being able to yield or pause the current thread and do something else in the meantime and resume the thread whenever we need to continue what we left off with that thread, in a way where we have more control over what gets executed before what. So let's go back to our script and let's delete everything that's over here. If we wanted to, let's say, make a coroutine that does stuff, but we also want our first task to do a little bit of stuff before moving on to the second one and then back to the first one, we can do that with coroutines, but we cannot do that with task.spawn. Let me show you what this looks like with task.spawn first. So we're going to say task.spawn, and then we're going to create a new function here. Let's write a while true do statement here, and let's just print some random stuff here with task.spawn, task.wait 0.01, and then down here we're going to write another while true do with print outside spawn, and then task.wait 0.01. Let's see what this looks like. If we hit run, then we should constantly see task.spawn and outside spawn running at the same time. But we're not going to be able to control doing specific things within one task and then doing specific things within another task and then switching back to the first one in a more strict order. We cannot do that with task.spawn, but we can do that with coroutines. Let me show you what this looks like with coroutines. Let's delete our task.spawn, and let's do this by saying local loop1 equals coroutine.create open parentheses close parentheses function open parentheses close parentheses enter. And down here, let's call the loop. Let's say coroutine.resume loop1. And we're going to have some tasks going on here as well. Let's say for I equals 1, 10, do, print I. So let's put another for loop here by saying for I equals 1, 10, do, and let's print I. And now down here, let's also make a check. Let's say if I equals 4 in this case, then what we're going to do is pause our coroutine by saying coroutine.yield open parentheses close parentheses, and then down here, let's resume our coroutine again by just copying this and putting this down here. Now let's run the game and see what happens. The order in which I printed this stuff out is very interesting. Basically what happened here is that I started execution of my coroutine, which I basically started at 1, and then it kept printing the number, and it's constantly checking whether the number reaches 4. So once it reached 4 down here, it basically stopped, and then it went to our outside for loop to print 10 numbers. And then it continued our coroutine after it was over, where it stopped at 4, and then it just kept on repeatedly continuing until it reached the 10th number, and that's where the coroutine ended after we resumed. It ended at 10. So what I'm trying to get at here is you can't have this level of control over what gets executed when you're using task.spawn over coroutines. I really hope this makes sense. In essence, coroutines let you have more control over what gets executed when you're running multiple tasks. It doesn't work the same way with task.spawn because it's basically like two different threads running individually, while with coroutines, you have two different tasks, but they sort of run interchangeably depending on how you handle these coroutines. So that's pretty much going to wrap up coroutines. It is a pretty complicated concept. So if there was something you didn't really understand about coroutines, I would advise you to rewatch this video and also maybe try and watch other YouTubers who also cover the same topic of coroutines. Maybe their explanation will help you into fully understanding how coroutines work, and also just try to apply these inside of your Roblox games. With more practice and more familiarity, and just pretty much understanding how coroutines and multi-thread processing and all of these other concepts put together work, then I think you'll generally have an easier time implementing these in the future if you decide to use them. Because coroutines are basically an indispensable concept that are used quite a lot for script multitasking and general stuff like that. It's very tough, but part of the journey that's fun is just figuring this stuff out. And then once you have figured this stuff out, it feels so rewarding too that you now know a complicated concept that you didn't previously know about. And that's just what's really fun about it. So I hope your journey serves well for you, and I hope you found this video to be helpful. Join my Discord server, the link is in the description, and I'll see you in the next episode. Take care. Ooh, free tacos. I am quite hungry. Oh no. It's raining tacos from out of the sky. Okay, okay. You might ask what the heck that was about. That was pretty.
Oh, guys, I didn't talk much, and not talking makes me feel sleepy. Dang, man. Wait, so coroutine, right? So I can make the thing that person make. I can make it change color at the same time, right? I can also do that with tax.spawn, right? But for the sake of it, let's do. Here, look at this, okay? This is disco. Yeah, you look at that. That is disco, right? I'm done. I'm tired. See you guys tomorrow. Bye bye.
Bye.